Okay, here's a little video on molecular compounds, writing names and formulas. There have been some requests for that. So here we go. The main thing that you need to know for these is they involve the use of prefixes, which makes the writing of the formulas and the names much easier. Sorry about the pounding in the library. Sometimes on the prefix, the last vowel is dropped if it makes the name sound weird. So let's look at some of these. Mono, di, tri, some of those you're familiar with. Tetra you may not be as familiar with. Hepta, but most of those you will have seen before somewhere. Um, these compound names, well, these compounds only have nonmetals. Those are the things clear to the right on the periodic table. And we are not concerned about the charges yet. That was only for ionic. When you get to AP, there may be some charges to deal with. Prefixes are used to denote the number of each element in the compound, and we tend to make these binary. The first chemical formula that you ever knew was probably H2O. The second was probably not long after that, CO2. You may not remember ever not knowing those. But both of these are both binary compounds and only nonmetals. So they're covalent bonds, molecular compounds. So H2O, or water, could also be named using prefixes, and it would be dihydrogen monoxide, 2 for the di for the hydrogen, H2, mono for the oxygen, 1, monoxide. Sometimes people will put that on a test just to see if you've been paying attention. And then CO2, carbon dioxide. Frequently we don't use the mono on the first element. So CO2 is pretty important. I used to put that on tests and people would miss it all the time, and I don't know why. You always knew it. It's like for some reason once you get to chemistry you lose your mind. The only mono I always require is on carbon monoxide, and there are lots of good reasons for remembering that one. So check with your teacher, see what she wants or he wants for the monos. Okay, the subscript determines the prefix. So here we got SO2, SO3, NO2, NO3, N2O4, P2O5, and P4O10. If you want to pause here and see if you can come up with the names of those, that'd be a good idea. So you may do that now or not. Okay, if you paused and you've restarted now, here's the names that I got. SO2 sulfur dioxide, SO3 sulfur trioxide, NO2 nitrogen dioxide, NO3 nitrogen trioxide, dinitrogen tetroxide for P2O, N2O4, diphosphorus pentoxide, and tetraphosphorus decoxide. Notice I don't say pentaoxide or tetraoxide. It's just we leave off those A's at the end. So here are some, now if you've got formulas and you're writing the names, see they don't all have to be oxygens, oxides at the end. Some of them are, some of them aren't. So here we go again. Oxygen difluoride, silicon dioxide, sulfur hexafluoride, nitrogen triiodide, dinitrogen monoxide. Again, if you want to pause and try these on your own and then come back and watch the what I think the answers are. So you could pause now or not. Okay, if you paused and you've restarted, here are the formulas that I got. Oxygen difluoride, OF2. Again, I didn't say monooxygen difluoride. SiO2 for silicon dioxide, SF6 for sulfur hexafluoride, NiI3 nitrogen triiodide. I think you need both of those I's. And then N2O for dinitrogen monoxide. And again, is dinitrogen oxide good enough? Talk to your teacher. Okay, so really these are not very difficult, and I think you'll be okay. Don't know if I'm still recording or not.